Atomic radius is the distance from an atom's nucleus to its outermost electrons. But why does it change across the periodic table? As you move right across a period, the number of protons increases, creating a stronger positive pull that draws electrons closer. However, as you move down a group, new electron shells are added. These layers shield the outer electrons from the nucleus, causing the atomic radius trend is a fundamental key to understanding chemical reactivity across the entire periodic table.
Understanding the size of atoms is key to chemistry, but what happens when they become ions? Metals, found on the left, lose electrons to form cations. As they lose an entire outer shell, the ion becomes significantly smaller than the original atom. On the right, non-metals gain electrons to form anions. The added electrons push each other apart, making the ion larger. As we move down a group, the ionic radius increases with each new shell. Across a period, the increasing nuclear pull draws the electrons in tighter. Master these trends, and you master the periodic table.
Ionization energy is the power required to remove an electron from an atom. But this energy isn't the same for every element. As we move down a group in the periodic table, ionization energy decreases. This is because the outer electrons are farther from the nucleus and less tightly held.
Moving across a period from left to right, ionization energy increases. The nucleus gets stronger, pulling electrons in more tightly and making them harder to remove.
Look at this trend chart. Notice the peaks at noble gases and the valleys at alkali metals. Understanding these trends helps us predict how elements will react and form bonds.
Have you ever wondered why some atoms are greedier than others when sharing electrons? That is electronegativity. It is a measure of how strongly an atom attracts electrons in a chemical bond. Think of it as a microscopic tug of war. Across a period from left to right, atoms get better at attracting electrons as the nucleus becomes more positive. Down a group, electronegativity decreases because the outer electrons are further from the nucleus pull. This difference determines if a bond is polar, like in water, or nonpolar. Now you know the secret of atomic attraction.
From the tiniest particles to the grandest structures of the cosmos, one map has guided our understanding. It is more than a chart. It is a language. A universal code that deciphers the building blocks of everything we see, touch, and it fuels our innovations, powers our technologies, and unlocks new frontiers in medicine, energy, and beyond. The periodic table is not just a scientific achievement. A reminder that every element holds a story, and every discovery is a step into the unknown.